Hey guys, so today we're going to be talking about analyzing graphs and discussing their relationship between the x and the y variables that are identified on those graphs. So today our warm-up is going to be a video. So go ahead and head your journal. It's going to be 2-1 graphing relationships. Today is the 16th of September. I want you to go ahead and put 1, 2, 3, and 4 in Roman numerals. That's going to match up with the question on the video for the warm-up. And once you're ready, we will begin. So before I give you the actual question, I want you to, we're going to watch this the first time, sort of discuss it, and then watch it for a second time. Okay, so now let's watch it for a second time. So here's a cylinder. We're describing the height and the volume. Now watch as we're filling up this cylinder with water, how they come up with the actual graph. Okay, now I want you to turn to your neighbor and discuss why this is a straight line just going up from left to right and very constant. Tell me why. Give you 30 seconds to do that. Now let's look at the second one. So it's a fishbowl. Okay, if you notice the fishbowl, when it started to fill up, it was sort of at a constant rate, but then it started to slow down a little bit because the width of the fishbowl is the widest in the middle. So notice it started to taper off just a little bit, but then as it started getting closer to the top, the width is actually shorter, so therefore it was going to increase more at a quicker pace. So what we're going to do is look at these 4 containers. It says the graph relates the height of the water to the volume of the water in each container. Which graph goes with which container? So I want you to do this by yourself. Look at these containers. Match up the graphs are 1, 2, 3, and 4, and just put whatever letter you think would be best when I fill them with water. And then I also want you to justify. So put a little short statement on how did you know that maybe A goes with 2. And so forth. So I'm going to give you about a minute or 2 to do that, and then you are going to share with your neighbor when Miss Osborne tells you to share, and then we're going to discuss it after you're finished. So go ahead and get started matching the graph with the container. Okay, let's start off with container A. Okay, which one did you think matches container A? What graph? A seems like the easiest one. This looks a lot like our cylinder that we just looked at, and that would match up with 1. The reason why is because it's constant. Okay, there's no change in the width of the container. It's just filling up constantly, so it should be at a constant rate. Also notice the height of the container. It stops here, while if you notice all the other ones are a little bit higher. If you notice that the A container is actually the smallest, so the height would have to be the smallest there. So A and graph 1 match up because it's constant. Let's look at B. Okay, which graph did you match up with B? I believe that B matches up with the 4th graph, and the reason why is because when I start filling this up, it's at a constant rate, and it's going pretty quickly because of how narrow the bottom of this container is. And then when we get to this point right here, okay, we start getting wider, which means it's going to fill up a little bit slower, until we get to gradually even, which means that the 4th one, again, it's filling up pretty quickly at a constant rate because of the bottom part of the cylinder. And then as we get into that funnel shape, okay, it's going to be a little bit slower, so it's not going to be going at a steep rate there. Okay, what about C? What did you get for C? We're left with 2 and 3. C I put with the second one. And the reason why I did that is because it's the widest at the bottom, which means it's not going to fill up as quickly until we get to the top. So it starts off by the really width, the widest part, filling up, and then we get really, really skinny when we get to the end, where that would be the steepest. Which leaves us with the third one, with graph 3 matches up with D. Here's our fishbowl that we looked at as the warm-up. Okay, so it starts filling up pretty rapidly, then it slows down as we get to the middle of the fishbowl, then it speeds up again, and then all of a sudden it speeds up really, really quickly because this is the most narrow part of the container. So the third graph would match up for that. So just to jot down some things in my notebook, you should have already filled this out, but we decided that the first graph matched up with container A because it was constant. The second one was C because it fills slowly because of the width of the container and then gradually gets quicker because the container gets narrower. D has the fishbowl, okay, so it starts off that little squiggly, I guess, way, and then it fills quickly up at the end because the steepest part of the container is the cylinder at the top. And then the fourth graph matches up with B because it fills quickly and then slows down towards the top. So just to give you an idea of what those pictures are again, here are the four. And this is what we're doing today. We're going to be matching up the graph with an actual real-life situation, in this case filling the container with the water. So what we're going to do is, again, we need to make sure we're able to analyze a graph. And noticing how steep the line is and how narrow it is, the container, and what's happening, those are important things we need to do to analyze this graph. So we're going to talk about some things that we notice. So we're going to make like a T-chart but with 3 columns. So keywords, we're going to write the description on the graph and then the way it looks. So if I think about keywords, if a container was filling up constantly, okay, it's just going at a constant rate. In this case, now they were filling up, the two things that they were describing was the actual height and the volume. So the height made it go up, but if I look at a graph, if something's going constantly, say you're driving a car and you're just going at a constant speed, okay, that's just going to look like a horizontal line. If I'm driving my car, it's going to look like a horizontal line. I'm not changing the speed. I'm going, it's sort of like cruise control. I'm going at the same exact speed, so I'm just staying horizontal. Some other words that we might see, if something rises quickly, okay, this might be a steep line, and most likely it's going to be going upward. Okay, so it would look something like that. Say they use the word rises steadily. Okay, this would again represent that it's inclining up. However, it's probably not as steep if it's rising quickly. So it probably is more like an angle. If something stops, how would you describe that? Again, if you're at a standstill, so you're driving your car and you're at a stop sign, okay, time moves on, but your speed doesn't change. So again, that could also be a horizontal line depending on the situation. if something drops sharply, again, that's probably going to be a very steep line that's going downward. Say a rock is falling slowly. Okay, again, that's going to be a decline. It's going to be going down again, but it's probably not as steep. So these are just a couple of words that would be used when you're describing something that's occurring with a real-world situation. So we're going to look at this a little bit more and just how to analyze the relationship on the graph. And when it comes to graphs, we use a lot of these keywords and descriptions of graphs when it comes to one type of graph that we have, but we're going to be looking at two of them today. So we have two types of graphs. And the first graph is what we looked at for our warm-up, and that's called a continuous graph. With a continuous graph, it sounds exactly like how it is. Okay, continuous means it keeps going and going and going. So, a continuous graph has connected lines or curves. The graph is unbroken. And I want you to put that the values of the independent variable can be measured. Okay, so once you have that written down, Miss Osborne's going to hand out a half sheet that should already be cut for you that has different types of graphs. What I want you to do is cut off 1, 2, and 3. So I'm just going to go ahead and cut that off. And I'm going to need the next page of my journal, so I'm going to flip it to the next one. And go ahead and take a second to glue that into the top, because we're going to identify the variables, and then we're also going to describe what the real world problem is in this case with analyzing the graph. Alright, once you have that glued in, divide it up into 3 sections. And the first part of this problem is we have to make sure, if we want to analyze this graph, we need to make sure we know what's going on. What are we describing here? And it talks about what are the variables in each of these graphs. Variables, again, are our x's and our y's in this case. So we need to make sure we're able to identify both. So for each graph, I want you to put x and y variable, because that's how we're going to identify what is going on. So if I look at this first graph, okay, my x variable, where is the x-axis here? Okay, it would be this horizontal axis, and this would be number of pounds. And the y variable here goes up and down, okay, so that would be the total cost. So in a second, what you're going to do is figure out a situation that talks about the number of pounds and the total cost, how they're related, and the actual continuous graph with the steepness, what could have occurred at this point right here to make it change. So you're going to sort of create your own problem with this actual graph. Okay, the second one, what is the x variable for the second one? That would be time. And the second, or the y variable for the second graph would be the grass height. And then the last one, our x variable, again on the x-axis, is the area painted. And the y variable is the amount of paint in a can. Okay, so what I want you to do is work with your neighbor on the actual situation. So I want you to describe how the variables are related at the various points on the graph. So again, if I'm looking at the first one, I'm deciding, okay, what happened here from here to here, and then what changed to make it go a little bit not as steep. Okay, same thing here. If I start here, what happened at this point, all these specific points, what happened? Okay, same thing here. What occurred? What do you think would have happened when you analyze this graph using those x and y variables? I'm going to give you about 5 minutes to work on that with a partner. Just write underneath what you think occurred, and then we're going to share them together. Okay, so after you've shared with your neighbors, hopefully you've come up with something similar to what I have. For this first graph, what I'm looking at, my variables, are the number of pounds and the total cost. So I'm thinking I'm at the supermarket buying meat or something like that, and I need to purchase pounds of meat. So I'm going to be purchasing a certain amount, and as the price goes up, at this point, that's where I'm thinking there might be a discount. So say you buy 5 pounds, and then you get a discount in your price. It's not free, but you get a smaller amount of maybe, like, instead of 50 cents per pound, it's going to be 25 cents per pound. So it's not going to be as steep. So what I would say for this one, and you could have had something totally different, but that's what I came up with, is as the number of pounds increases, the total keeps going up. And then there's a discount, and then it just goes up slowly. So that's how I would describe or analyze this graph. As the number of pounds increases, my total keeps going up, but then I hit a discount mark, and then it goes up slower, not as rapidly quick or fast. Okay, now the second one's a little bit easier, I think, if I'm talking about the grass height and the time. I think a lot of you guys probably got this, but as the grass height increases, then all of a sudden it stops and it drops back to where it started. Okay, so then it increases again, then it stops, and it drops all the way back down to where it started, and it keeps doing this. So, in this case, the way I would describe it is the grass is growing, and someone is cutting it. How many times did it get cut in this graph? It grew, it got cut, that's 1. It grew, got cut, that's 2. It grew and got cut, that was 3. So it cut it 3 times. Now if you notice, you could have also put from this time, how this one's the highest, it grew the highest, and then it cut, and then it didn't grow as high. But it looks about the same amount of time was spent, so maybe 3 days it was cut, 3 days it was cut, maybe we got more rain here. So you could put something like that, anything at all, okay? It's just analyzing it based off of what you think happened. And again, all of these choices on the EOC are going to be multiple choice questions, so you just have to analyze the graph as you're reading the answer choices. And then this last one is amount of paint in a can and the area painted. So again, we start off with a lot of paint in the can, but as the area of paint increases, because I'm painting more and more rooms, obviously the amount of paint in the can is going to decrease, and I'm eventually going to need more paint. So I'm going to put the area painted increases, but the amount of paint in the can decreases. Okay, so that's our first type of graph, is continuous. It's showing it's not broken, okay, it's very continuously, it's just telling a story, you can analyze what's happening from the graph. Okay, now the second type of graph, and it looks similar to one that you studied last year, is called a discrete graph. And it looks sort of like a scatter plot in some ways. Okay, and what this is, it's not going to be connected lines, it's going to be distinct points that are not connected. And the values of the independent variable can be counted. So again, continuous, the independent variable, we could measure it or estimate. This one, for discrete, is that they are counted. So let's do an example before we actually look at some more. I'm going to make one up as we go. So go ahead and draw quadrant 1 of our graph. And again, we always have to identify the two variables. So let's say this is candles sold and amount earned. And some other information I'm going to give you is the actual T-chart. So let's say our X and our Y. Again, remember X was our candles sold. And Y is the amount earned. So I'm going to give you some information. Okay, let's say one candle sold will earn me $5. 2 candles sold will earn me $9. 3 candles sold will make $12. 4 candles sold will be $15, and let's say 5 candles sold will be $25. Now, how would I tell if this is a continuous or discrete graph? Well, if I think about it, this is a discrete graph because can I have 1.5 candles sold? No. Can I have 3 1/4 candles sold? No, it's whole candles. So that's why these are distinct points. If I actually graph these on the graph that we just created, again, there's usually no numbers, it's just talking about, I don't know, you just have to estimate. So 1 and 5. So let's say candles 1 here, let's say this is 5. 2 would be here, and it's about maybe 9. 3 is 12. 4 is 15, and then 5 might be 25 way up here. So notice it's not continuous, it's not evenly distributed every single time. If I look at my Y values, it's not going up by the same thing every time. 5 to 9 was plus 4. 9 to 12 was plus 3. 12 to 15 is plus 3. And 15 to 25 is plus 10. So it's not a linear equation here. It's not going up continuously. It's just distinct points. The candles sold tells me that information. Okay, so what we need to remember when it comes to discrete is that these X values are given as whole numbers. I don't have a half of a candle. I can't have a half of a candle. So that's why we have those as whole numbers. Okay, once you're done with that, I want you to take the other part that we just cut off 1, 2, and 3 from. Now if you notice, it's 4, 5, and 6, and these are all discrete graphs. I want you to glue that in, and then once you're done gluing that in, I want you to match each graph with the table based off of the discrete points. Okay, so I'm going to go ahead and put 4, 5, and 6, and I'm going to go ahead and see which one matches up with the data table. So I'll give you a couple minutes to work on that. When everyone's ready, Miss Osborne will push play. Okay, once you have that done, what I did is I always look at the table and I look at, okay, what is this going up or down by every time? So 91 to 89, it went down 2 degrees. Then it went down 8 degrees. So that's a steeper fall. And then it went down a lot. Again, I'm just looking at this to sort of describe what happened. Okay, so if I look at what happened, it went down 2 degrees. So not much of a difference between 1 and 3 o'clock. Then it went down 8. And then it went down a lot. So it went down a lot, like really steep. So in that case, I believe 5 would be A. Okay, if I look at this next one, this went down 1 degrees, down 1, down 1. So it's pretty constant going down, not by a lot every time. And it looks like 6 would be the best discrete graph that would describe that. And this last one, it went up 2%, or 2 degrees, sorry. Then it went up 1. And then it went down 6. So if I look at this last one, okay, here's 24 degrees. It went up 2, then it went up 1, and then it went down 6. So C would be the best for the fourth one. Okay, so again, our 2 types of graphs are continuous and discrete. Okay, remember, continuous is a graph that's unbroken. It tells us a story, a relationship between the x and the y variable. Discrete graphs do as well, however, it's just distinct points. Okay, I wasn't talking about 1:37 p.m. here or 3:35 p.m. Okay, these are distinct times that they used. So the last thing you're going to glue in, Ms. Osborne will give you this. It's just, again, a sum of what we talked about today. So it's a key concept, continuous and discrete graphs. So go ahead and glue that in. And then when you're done, keep that open on your desk, and Ms. Osborne will push play and I'll discuss what we're doing for the rest of the class. So as you have that open up on your desk, again, you have your notes about continuous and discrete graphs today. What you're doing for the rest of the class period, which isn't long, is your exit ticket. So this will be turned in before you leave class today. So you will not have homework over the weekend. And this is very similar to what we did in our notes. So make sure you go back in your notes and look. Okay, 1, 2, and 3, these are all continuous graphs. I want you to tell me what are the variables in each of the graphs. So I set it up for you, x and y variables for each. And then I want you to describe what happens to the graph with analyzing it. Okay? And then 4, 5, and 6, again, you're just going to match each graph with the table. You don't need to explain anything, but I do want to see how you were thinking. So make your little carrots and tell me if it was going up or down, and that will help you describe which graph is related to the table. So once you're done with those 6 problems, turn it into the tray, and then you can sit quietly at your desk, all packed up, ready to go when that bell rings. Have a great weekend, and we'll see you on Monday.